Welcome to clickmyproject.com. Now we discuss about the product reversible data hiding in encrypted images based on progressive recovery. Now we discuss the abstract for the process. In this paper proposes a method for reversible data hiding in encrypted images, that is the known as RDHEI, based on progressive recovery. Three parties are involved in the framework, including the content owner, the data hider, and the recipient. The content owner encrypts the original images using a stream cipher algorithm, that is the RDH. One of the RDH upload a cipher text to the server. The data hider on the server divides the encrypted image into three channels, that is the respectively three number of bands in the RGB image that embedded different amount of the additional bits into each one of generate and marked encrypted image. On the recipient side, additionally, message can be extracted from the marked encrypted image and the original image can be recovered without any error. While most of the traditional methods use the criterion to recover the whole image, we proposes to do recovery by the progressive mechanism. Rate distortion of the proposed method outperforms the state of art in the RDHEI methods. Hence, this process is well efficient to both the encryption and decryption by using the RDH method, though the errors will not be occurred, and if the error is occurred in the retrieval means the estimation is carried to how much of error content built in the image by using the PSNR estimations. Now we discuss the overall flow diagram for the process. This is the overall flow diagram for the process. At first, the input image is taken from the dataset. The dataset is the folder which consists of several input images. After getting the dataset image, the pre-processing is carried out. In the pre-processing step, we have to consider the noise filtering. In the noise filtering, we used the median filtering method to filter the noise in the image. After the noise filtering, the noise-free images get out from the pre-processing. Then the key generation is carried out. In the key generation process, we have to consider the two procedures. One is the user could enter the key. For example, if the user enter the key 123 means the key will be automatically generated and then locate the corresponding size in any image size. Then after locating the key in the image, the RDH algorithm is applied to encrypt the image. After the encryption is carried out, the embedding the data into image is carried out. The embedding is the process to embed the text file into the image. After the embedding, the encrypted image is again enter the key in the decryption side. If the decryption side, the receiver should enter the appropriate key. If the key is wrong means the user can again enter the key. Again, if the key is correct means the decryption will be carried out. In the after the decryption, the reconstruction and the output generation is carried out. Then the after output generation is carried, the PSNR and MSE estimation is carried to estimate the accuracy of the process. Now we can discuss the initial running procedure for the process. At first, open the MATLAB 2013 and change the current directory as it is in the code. Now you can see the main_GUI.m. If you want to execute the code, right click in that file and select the option Run. Now the GUI design was opened. In that you can see the several push buttons and the edit box, as well as you can see the axis in the right side. The push buttons are used to select the option and for the controls. The axis is used to display the image. Now click the button Image 1. After clicking the button Image 1, the dataset folder was opened. In the dataset folder, the several images is carried in that dataset folder. Now select any one image from the dataset. After the selection of image, the selected image is shown in the axis 1 with the title Input Image. Then click the button Pre-processing. After clicking the pre-processing, the filtering is applied in the image and the corresponding filtered image is shown in the axis 1 with the title Filtered Image. Now enter the key as 123 and click the button Encrypt Image. Now the encrypted image is shown in the axis 1 with the title Encrypted Image and the message box for the encryption is shown. Now click the button OK and once again enter the key, then load the data. Now select the text file from the Get Data folder and click the button Open. Now the message is embedded into the image. Now click the button Encrypt Data. Now the encrypted data is shown in the edit box. Now once again enter the key and submit. Now you can save the image as an BMP format in any folder. Now I save the file as an 11. Now click the button Save, then click the button Next. After clicking the button Next, the decryption side will be carried out. In the decryption side, you can enter the same key and click the button Submit. Now you can select the saved file from the folder, then once again enter the key, then click the button Submit, then Open. Now the hidden data and the corresponding image is shown in the axis 1 and the edit box. Now if you enter the same key again, means the original data is shown in the edit box and the respected PSNR estimation is shown in below. Now the PSNR value is 47.4. Thanks for watching this video.